Here we go. This is the review for the test on periodic table. So identify which of these elements matches the descriptions. Elements with properties of metals and nonmetals. So the elements with properties of metals and nonmetals are called the metalloids. And they follow along a line that goes right down here, this. And all the elements except aluminum that fall on that line are called metalloids, which have characteristics of metals and nonmetals. So in this case, the answer would be either H or B. Either one would be correct. Representative elements. The representative elements are all of the elements in the first two columns and all of the elements in the last six columns. So in this case, they're actually all representative elements except for this one down here, which is choice G. The ones that will react violently with water and oxygen are the alkali metals, which are in this group here, the first column of the periodic table. The answer there would be D. Noble gases are the elements on the far right-hand side, so element A would fall into the noble gas category. The number of valence electrons is related to the groups for the representative elements. So all of the elements in the first group have one valence electron, which means element D. The ones in the second group would have two valence electrons. Then we jump over to 13 has 3, up to 18 has 8. Properties similar to carbon. Well, carbon would be right here in the periodic table. So the element with properties similar to carbon would have to be in that same group, which would be H. 5 valence electrons means that you have an element that's in group 15, and this is group 13, 14, and 15. So for this one, either E or B would be correct. The alkaline earth metals are all the elements in the second column, so that would be element I. The first column are the alkali metals, the second column is the alkaline earth metals. The actinide series, the actinides are all of the elements in the very bottom row of the periodic table. The elements in this row are called lanthanides. The elements in the bottom row are called actinides. So that would be G. The scientist who identified the law of octaves was John Newlands. Dmitri Mendeleev is credited with the first modern periodic table, and Henry Moseley modified Mendeleev's periodic table to account for the number of protons being the identifying factor rather than the atomic mass, which was how Mendeleev did it. And Arthur Dent is the main character in The Hitchhiker's Guide to the Galaxy. Poor conductors of heat and electricity, that would describe the type of elements called nonmetals. D, nonmetals. For storing highly reactive elements, you want something that doesn't react with other elements, and the group of elements that does not react are the noble gases. Which of these is a non-metal? Nitrogen is a non-metal. Sodium and magnesium are both metals, and boron is a metalloid. The non-metal is nitrogen. If you were looking for something that was a noble gas, you would look for something that is unreactive with other elements. That's what defines the noble gases. That's why they're called noble gases, because they don't interact with others. Elements in the same period have electrons, valence electrons, that are in the same energy level. Each row represents an energy level on the periodic table. The same number of valence electrons would be in the same column going up and down. The same energy level is the groups, or the periods or rows going across. The most important characteristic in determining an element's chemical properties is the number of valence electrons. The valence electrons determine the properties because the valence electrons are the ones that participate in any chemical reactions. Which group has one valence electron and is highly reactive in water and air? Well, either one of those descriptions would be an alkali metal. Those are the elements in the first column on the periodic table. Alkaline earth metals are in the second group. Halogens are in group 17, and the actinides are the elements down at the very bottom of the periodic table where uranium is. An element with 6 valence electrons, that means the element is in group 16. The element in this group that is in 16 is oxygen. It has 6 valence electrons. The property that describes how strongly atoms pull on electrons of other atoms when they're in a bond, that's called electronegativity. The highest electronegativity on the periodic table is fluorine. The lowest would be francium. And all the elements in between, the electronegativity gets higher the closer they get to fluorine. The atomic radius tends to decrease as it goes from left to right and increase as it goes from top to bottom. So the choice that matches that pattern is choice C. Okay, which of the following has the greater ionization energy? Carbon or neon? Ionization energy increases from left to right, and neon is on the far right-hand side to the right of carbon. Which has the greater atomic radius? The element farther to the left generally has the greater atomic radius, and aluminum is to the left of sulfur. Electronegativity increases from left to right, not counting the noble gases. Bromine, being a halogen, is very close to fluorine on the periodic table. It has a much higher electronegativity than potassium. Atomic radius, as you go down, both rhenium and manganese are in the same group or column. Rhenium is lower than manganese, and as you go down in a group, you get bigger atomic radius. Greater radius, the neutral chlorine atom or the chlorine ion, which is negative. A negative ion is always bigger or larger radius than its neutral atom. A positive ion would be smaller than the neutral atom. Ionization energy, a higher ionization energy. Well, ionization energy decreases from top to bottom. Lithium is in the same group, the alkali metals, with cesium, but lithium is at the top, so it would have a higher ionization energy than cesium, which is down close to the bottom. There's an element with similar chemical properties to carbon and germanium. It has an atomic number greater than neon, but less than sulfur. Which element would this be? So the fact that it has similar properties to carbon and germanium means that it would be in the same group, which is group 14. The atomic number greater than neon but less than sulfur tells you that it's an element in between carbon and germanium. And the element that falls into group 14 between carbon and germanium is the element silicon. Why is the atomic radius of fluorine smaller than that of nitrogen? Well, nitrogen and fluorine are in the same period of the periodic table, the same row. Fluorine is farther to the right. And what happens is, as you add electrons to the outer energy level of an atom, you're also adding protons to the center, to the nucleus. So the number of protons in nitrogen is 7, and in fluorine it's 9. Those 9 protons are pulling on electrons that are on the same energy level as the 7 protons of nitrogen. So these 9 protons are able to pull the electrons in closer because they're essentially more concentrated than they are in the nitrogen. So the nitrogen is a little bit bigger because those 7 protons can't pull on the electrons as much as the 9 protons in fluorine, and that is why fluorine is smaller in radius than nitrogen. Why is the second ionization energy of calcium higher than the first? Well, this is a similar answer to the last one. You've got the protons in the middle and the electrons around the outside. Calcium has 2 valence electrons. Well, the protons are pulling on these electrons, but when calcium is neutral, they're sort of equally matched. When you take away the first electron from calcium, that means now you have more protons than electrons, which means that the protons are able to pull all the remaining electrons even closer. The closer they get to the nucleus, that second electron is now much harder to pull away, takes a lot more force than the first one did. So that's why as you take electrons away, each successive electron gets harder to take because the protons are able to pull the remaining electrons closer and closer and closer together. Why is the ionization energy of fluorine higher than that of all the elements in its period except neon? Because of exactly what we said when we talked about the radius of nitrogen versus fluorine. Fluorine in that row, except for neon, has the most protons in its nucleus. It also has more electrons than nitrogen and carbon and the other elements in that row, But because the protons in fluorine are able to pull the electrons closer than the ones for, say, nitrogen or carbon, then it makes it harder to get those electrons away. And the ionization energy is the measurement of how hard it is to get the electrons out. So the closer they can get to the nucleus, the harder it is to get them out. Therefore, the ionization energy goes up. Boron is larger than fluorine because there are fewer electrons in boron and they are in the same energy level. Now, fewer electrons you'd think would make it smaller, but again, we're talking about the comparison of electrons and protons. There are fewer electrons in boron, but there are also fewer protons pulling them together. So that's why boron is larger. As the number of energy levels increases, there is less proton-electron attraction because you've got the protons. As you add energy levels, right, these electrons out here are a lot farther away than these in here. So the protons are pulling really strongly on these center electrons, but they're pulling much more weakly on the electrons at the outside because they're A, farther away, and B, all the other electrons in between are sort of shielding the outer electrons from the protons. So as there is less proton-electron attraction, the ionization energy decreases. So the more energy levels, the lower the ionization energy gets. The calcium ion has less electrons, that's why it's positively charged, than the calcium atom, and therefore the ion is smaller, as we talked about before. Take away electrons, the remaining electrons get pulled closer in, makes it smaller. Positive ions are always smaller than the neutral atom. Negative ions like chlorine are always bigger than the neutral atom. Draw the electron dot diagram for the following elements, sodium and nitrogen. We did this toward the end of the last chapter as well. What you really need to know is how many valence electrons are there? Well, sodium is in group 1, which means it has 1 valence electron. So to draw the dot diagram, you put the symbol for sodium, Na, and then you add 1 dot for the 1 valence electron. You could put it on any of the 4 sides. Nitrogen has 5 valence electrons because it's in group 15. So we're going to add 1, 2, 3, 4, 5 valence electrons. And there's the dot diagram for nitrogen. Okay, so here is the periodic table puzzle. Lithium has 2 energy levels and 4 outer electrons. Well, 4 outer electrons tells you it's in group 14. And 2 energy levels means it's on the second row. So second row, group 14, would put LV right here. Computer chipium is important semiconductor for computers. Well, that tells you that it is silicon, which is right here. It's a metalloid. Lithium is the lightest of elements, which is hydrogen. Hydrogen is the lightest element. Breathium, when combined with lithium, makes the most common liquid, L2Br, so that would follow the same pattern as water, which means that breathium is the same as oxygen. Okay, francium is group 13, period 4, but this francium is in group 13 and in the 4th row. Muonium has the atomic number 34, so you'd count to number 34, and you get the element that would be right here, element number 34 on the periodic table. Explodium is the most reactive metal. That would be the one in the bottom left-hand corner. Violetium is found as part of a compound in bananas and has violet-colored flame. We found this in the flame test lab that we did. That's the same as potassium, which would be right there. Sparkium and bernium are in the alkali metal group, along with explodium and violetium. The reactivity from least to greatest. Greatest is explodium, then violetium, then bernium, and then sparkium. So that takes care of the alkali metals. Ballonium is a noble gas used to fill balloons. Well, that would be helium, which would be up here. Toothium is added to juice to help build strong bones. Well, toothium, that sounds a lot like calcium, which would be right here. Metalloidium and poisonium are found in period 4. Poisonium is more massive, which means heavier than metalloidium. So we're going to say that poisonium is bigger, which means it's going to be to the right of metalloidium. Lowigium is a period 4 halogen. The halogens are group 17. Period 4 is here. So we go to LO, 17, period 4. Dark bluium has a mass of 115. Well, you have to look on the periodic table to find 115, and it's going to be the element here. Hugium is the most massive element on this periodic table, which is going to be the bottom right. They get more massive the farther down, the farther to the right you go. Glucinium is in period 2, group 2, so that would put it right here. Reactinium is the most reactive non-metal on the periodic table. Well, the most reactive non-metals are in the upper right-hand corner. Fluorine would be the most reactive. Polonium, signium, and stabilium, supermanium, hugium are all noble gases. So we've got polonium already, and they are arranged here from least to most massive, which means we've got polonium as helium, and then we go down signium, stabilium, and supermanium, and then hugium we already have at the bottom. Canium is used to help preserve foods in can manufacturing. That would put it down here as the element that we call tin cans. Bernium, blue whitium, bauxitium, computer chipsium, bringer of lightium, stinkium, purium, stabilium are all found in period 3. Bernium we already have as 1 electron. That's the alkali metal. Blue whitium has 2. Remember the blue white light we got from magnesium. Bauxitium has 3 valence electrons. That puts it here. We've already got computer chipsium, bringer of lithium. That would be phosphorus. Stinkium would be sulfur. And purium would be chlorine. And they have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons from left to right. Scottium is a metal element found in group 2. So the only element left in group 2 is the last one at the bottom of the group, so that's scottium. Infectium, when mixed with alcohol, can be used on cuts. That would be iodine, which is down at the bottom of the halogens in this periodic table. Abundantium is one of the most abundant gases in the universe, which has 7 protons, 7 neutrons, and 7 electrons. That would be nitrogen, and that would be right here in group 15 on the periodic table. And the number of electrons in the outer energy level of nautolonium is 5. So 5 valence electrons means group 15. So that's going to put it in the last place in group 15. Earthium has 6 valence electrons, so that's going to be in group 16. And then the last one, boracium, is in group 13. It has 3 valence electrons, which puts it right there in the same place as boron. So there you go. That fills in the periodic table. The one on the actual test will be smaller than this, but the same concept where you're given clues to fill in a blank periodic table. Make sure you know the scientists who created the periodic table, the different groups, such as alkali metals, alkaline earth metals, halogens, noble gases, transition elements versus representative elements, how to find the number of valence electrons with the periodic table, 1, 2, 3, 4, 5, 6, 7, 8, and how to find an element based on its properties, metals versus nonmetals, and metalloids. The metalloids are in this group here, along that zigzag line. Also, how to find an element based on its location. What row and group is it in? What period and group is it in? Be able to navigate around the periodic table.